Hi everybody, welcome back. So we're going to do something a little bit different on this video. We are going to do a repair of a Kenwood, let me see if I can bring it up in front of you here, a Kenwood model KR-710 stereo receiver. Now this was kind of like the entry-level line in the 1980s of this line of stereos by Kenwood. And it was actually, one of these was the first stereo receiver I actually purchased brand new. Prior to that, anything I owned in the past was all used equipment that I picked up elsewhere. But this was the first one I bought brand new. I heard it in one of the audio stores in the area, and I was so impressed with the way it sounded for being such a small and inexpensive receiver. It's only 28 watts per channel, that I actually bought it. And I had that thing for a lot of years, and it ended up disappearing in my college years. But I picked this one up online because I saw it on eBay. It apparently has some kind of problems, and I think they're pretty major. I don't know, but it won't power up. It doesn't work. So we're going to troubleshoot it. But really what we're going to do a little bit different this time is I did that video, I think it was a little Marantz receiver or something, a while back, and I did just a back to basics troubleshooting video, and that one seemed to get some pretty good popularity. So I'm going to do another one of those today doing this, and we're just going to try to once again use minimal equipment, something that you would have if you were just starting out. So I really want to try to stay away from the oscilloscope in the beginning if we can, and things like fancy signal generators and things. We'll try to use some inexpensive tools that anyone can get online. The one caveat is my digital multimeter is a fluke. These are expensive, but you don't have to have one of these. You can get a meter that does exactly the same thing, that's a lower cost online, and you can get these things for 40 or 50 bucks for a decent one. And they even have really cheap ones if you want, and they'll all measure voltage and ohms and things like that. So just know that you don't need to buy that one, just a digital multimeter. So if that sounds good to you, stay tuned. That's what we're going to do in this video, and we'll see how this turns out. I have no idea what's wrong with this thing, and I have no idea how deep we're going to have to get into it, but that's part of the fun. We're going to try to do it without using a ton of fancy test equipment. So when it comes to troubleshooting a piece of equipment and powering it up for the first time, there's kind of two trains of thought that you're going to follow on this, one or the other. One train of thought is this is your piece of equipment, you know it, it worked fine up until some point, and then it stopped working. But you know how it works, and you know it was plugged in and so forth. When you're going to troubleshoot that, you're going to approach it in a maybe a little bit different method in the very beginning than you would with an unknown. This one is unknown. In other words, we just have minimal information what's wrong with it. It came here through the mail, so we don't know what kind of banged around in there, or we don't know if somebody's even tried to work on this before. We know nothing about it. So the way we're going to approach this would be a little bit different than if it were my own equipment that I knew a little bit about. And the main difference is whether you power something up without investigating first. If it's something that's been sitting up in your room and you've been listening to it all along, and then one day it just failed, bringing it down here, putting it on the dim bulb tester and plugging it in, to see what's going on, isn't quite as big of a risk as something that you don't know. Even with a dim bulb tester, you will partially power this up, possibly, when you turn it on. And if there's something loose rattling around in there or disconnected, even some of the smaller components in here, especially in the tuner and the front end and so forth, if something shorted out in there, you could damage from some of the small signal transistors or some of the integrated circuits or something, just by some shorted out voltages in there, and cause yourself more things to repair than would have originally been necessary had you found that problem first. So since this is something that's an unknown, I always take it apart, take the cover off, and inspect it carefully for any kind of loose debris or shorts or any signs of somebody working on it and not putting it back together properly or anything like that. So that's what the first step we're going to do. So let me get the screws out of this cover and we'll take the cover off. Okay, let's make this video a little more interesting. Any tools that we use during this video, we're going to put in this box and keep them in here. And at the end of the video, we're going to take this box out and we're going to take an inventory and just see what all it was we needed to do this actual job. So hopefully we won't have that much in here. That's the whole idea, to see what the bare minimum is we're going to need. All right, we got the cover off and we're looking down here. And let me adjust the camera up a little to get you a little better view. Okay, I think we have the whole thing in shot there. All right, so looking down here at the inside of the receiver, it's kind of dusty, and you're going to see that whenever you deal with older gear like this that's been sitting around. And of course, what we're going to look for is any signs of anybody working on it, and any signs of anything that has come loose, or any foreign objects that are in here. Anything like that we want to see, and we want to be able to remove those things before they cause any damage when we plug it in for the first time. So looking around here, everything looks pretty clear. I mean, other than the dust, it doesn't look too bad. Right off the bat, we can see two fuses up here. Okay, and I'm not going to count my pointer because this is for showing you guys things, but there's one here and one here. And one thing we can do is we can test our fuses to see if they're okay. So let's use our meter. We're going to set our meter, our multimeter, to ohms. And we're going to go in here. We're going to just test these here. Let's see if you can see it all, get it all in shot. So fuse number 1, that's good. See, it's very low ohms. And fuse number 2, very low ohm. So I'm going to say that this is going to be okay to power up safely. And I'm going to explain what that means here in just a second. Now, anytime I go to power something up for the first time, or if I'm servicing something that there could be somewhere where something will short out, I always plug it into what's called a dim bulb tester. Now, I've talked about this many times in my videos, but those who are new to the channel or who have not watched any of my previous videos, this is what we call a dim bulb tester, or DBT. And it's very simple. There's 3 parts to it. There is an extension cord, just a standard mains extension cord, you know, with the plug on one end and this on the other. You can buy these at just a normal hardware store. You can also go in the electrical section of the hardware store and you can purchase one of these inline switches. It makes it convenient to be able to turn the device on and off from here instead of always having to turn the power on and off on your stereo or whatever it is you're working on. In line with that, you can see we cut one of the lines. Now, here in the United States, okay, I can't speak for every country, but whenever you look at these twin lead cables, there'll be one conductor that'll be smooth and one that'll have these little ridges on the side of it, these rough little ridges. The side with the ridges is going to be connected if you have a polarized plug, and you can see one prong is wider than the other. If you have one of these plugs that's polarized like this, the ridged wire will be connected to the neutral line, which is internally tied to earth ground in your breaker box. And the smooth conductor here will be connected to your hot line. So if you notice, what we've done is you kind of split the wire in the middle here, and we took the hot wire and we cut it, and we splice this light bulb right in series with that hot line. And then it goes out and ends up, as you can see, on this outlet. So what we're going to do is we're going to plug our stereo into this and turn our little light on, you know, our little switch on. And when this thing turns on, what's going to happen is the power going to the stereo will first have to pass through this bulb, because this bulb is actually in series with your power line. And what's going to happen is, if there is any heavy current, the bulb is going to absorb it, and this light is going to light up very brightly. And that's going to prevent excessive current from going through your stereo, and it's going to protect your power transformer and your power supply and any of the other components. If the stereo does not have a bad short in it, what's going to happen is this bulb will light up a little bit, and then it'll dim down. And it'll either glow very dimly, or it might go out altogether, depending on how big your bulb is. Now I'm starting with a 100 watt bulb. You can use a smaller one for more current limiting, and you can use a larger one for less current limiting, so you can swap them out. This is an industrial socket that you can also buy at a normal hardware store. I bought this one at Lowe's. And one of the nice things about it is it has a little rubber boot around it. So when you screw this down, you really can't come in contact with any of the electrical circuitry. So it's a little bit safer that way. So the idea of this is I can dead short this stereo. And if there's a dead short in there, this light will light up full brightness, but nothing's going to happen to the stereo. It'll be safe. And that's the whole idea of your dim bulb tester. Now, this particular stereo has a transformer in it, and that transformer is going to provide some isolation between your mains plug, you know, the plug on the wall that you plug your electricity in, and the actual device itself. And this is important because you don't want to be, you know, if you touch something here and then you touch earth ground, you don't want to be able to receive a shock. So transformers will actually provide that electrical isolation. Now in some older gear, like especially some of the old vacuum tube radios and things, they don't have a transformer. And one of your power mains wires will go directly to the chassis. And there's a lot more we can talk about that later. But in those instances, you would also need to use something like this, which is an isolation transformer. And what this does is it's whatever you put into the mains, you know, through your power cord, you get that same amount out of this, but it will be electrically isolated. So this plug will be electrically isolated from the outlet that you're going to plug it into. And that makes it a lot safer to work on. You can still get shocked, but there's less possibility of you touching something that is grounded or connecting a piece of test equipment, even more importantly, that's grounded, and damaging the equipment or yourself. So just remember, and again, there's lots of videos about using an isolation transformer. Maybe we'll do another video on that another time too. But we don't need that for this project. Okay, we have everything plugged in. We have the stereo plugged into the dim bulb outlet. We have the bulb sitting up here. We have our little switch up here where you can see me use it, and it's plugged into the outlet. I'm going to turn the power on to the stereo, but I'm not going to worry about it yet because this switch hasn't been turned on yet. Now what's going to happen is, as I turn this switch on, if there's power getting into the power supply, this bulb should flash on for a second as these two big capacitors charge up, and then it should dim back down. So what I'm going to do here is I'm going to shut the light off on the bench so that you can see a little more clearly what this bulb is doing while I turn it on. And we'll shade it a little bit, and let's see what happens. Okay, so here we go. We're going to turn it on. Did you see that? And you can see after it flashed on and then off, there is power in the stereo right now. But that bulb has so little bit of current in it that there's not enough current to make the filament of the bulb glow. So there's very low current flowing through this, which tells me there's no shorts in the stereo. But as you can see down here, the stereo is energized because the red power indicator is on, and the little green light down here, I don't know if you can see it or not, is also on. See it right there. So the stereo is powering up, at least. We know that much. Okay, now that we know that, let's get set up, and I'm going to turn this back off for a second. I'm going to set you up for the next test we're going to do. I have the stereo positioned with the back facing us because the next thing we're going to check is, we know there's no shorts that we could see, but even with that, this is one of those stereos you kind of have to be careful with. It does not have a protection circuit in it. And what a protection circuit is a circuit that if there is any type of DC voltage on the speaker terminals, a protection circuit will drop out a relay which will disconnect the output of the amplifier to the speakers, so that high DC voltage won't get onto your speakers and burn them out. This particular amplifier does not have that. How do we know that? Well, you can look in here physically and you can see that there's no relay or anything. If you really look around, you won't see any kind of relay or any kind of method of disconnecting the power. Now, some of the Harman Kardon and Carver and some of the other gear out there will use a solid state means of disconnecting the power from the transistor if it shorts. This does not have that. So really the only thing you can rely on is one of those two fuses blowing. And in some instances, what might happen is prior to the fuse blowing, you'll actually present your B+ voltage right onto the speaker terminals and again damage your speakers. So we certainly don't want to connect speakers to an amplifier unless we can verify that there's no DC voltage on the terminals. Remember, this amplifier supposedly did not work. Is what the word was on it, and that's all we know about it. So we're going to check the speaker terminals for DC voltage. And we're going to do that by turning this on. And I have the speaker A button selected so that these speakers are selected. I'm going to turn the amp on. And we're just going to go on to the terminals of the left channel and right channel. And look at that. 32 volts on that speaker terminal. And you can see this one has 0 volts. And right there is your reason you never connect a set of speakers to an unknown amplifier. That 32 volts there is showing that we have a shorted transistor. Now normally in a little higher end amplifier there would be a relay circuit called a protect circuit that would prevent that from happening. This particular amp, when this thing failed, it probably destroyed the speaker that was connected to it. Now you may ask yourself, what would happen if I had a set of speakers connected when this amplifier failed in this manner? So what we're going to do is we are going to sacrifice a speaker to the cause here. This is an old speaker that is in poor condition. The surround is all messed up. I really don't care about it. I have spares of these. So we're going to look and see what happens when we connect this. And I'll kind of put it in a little side profile so you can see what happens here. And I'm going to turn this on. Now the dim bulb tester is on here, remember? And what you're going to see is probably what's going to happen is this will light up to limit the current somewhat. That'll prevent the fuse from blowing, but I think it's still going to destroy this speaker. We'll see. All right, here we go. And you see what happens? Do you see how it pulled that back? And this voice coil's hot already. Now, it didn't blow it up, but as you can see, I mean, we'll do this one more time. There, I just turned it on and off. But you can see all that power would go right into the speaker. And if this dim bulb tester were not on there, we would have instantly burned up that voice coil because the coils in these little speakers are so tiny. So that gives you an idea of how dangerous this is to your speakers. And that's also why I never just plug things in when they're an unknown stereo. I always go through this test process. So make sure you do the same if you're new to this hobby, and it might save you some speakers, your bench speakers that you use for testing things. We now have the bottom cover off, and this particular stereo, the only thing that holds the front and the back apart or together when you take the bottom cover off is the 2 heat sinks. So you have to be very careful working on this from now on because it's going to be very flimsy. Again, this was the entry-level stereo for Kenwood at the year that this came out, so it is not, it was built somewhat to a cost. And you'll see that any of their audio gear from this era kind of has this type of build quality. It's good equipment that performs well, but the actual mechanical design, these circuit boards are very delicate. They will crack very easily. You just have to be careful working on these. It's a good stereo once you get them running, but you just have to be careful when you're inside servicing them. So we don't see any signs of anything being shorted or burned up or anything like that, and you won't typically with failures like this. So what we're going to do is we're going to go through and we're going to check our transistors, and we're going to start by looking at the outputs. Now, there's 2 ways that we'll be able to approach this. The best way is if we have a schematic. If you don't have one, you can usually identify the components to be able to test them. So the output transistors are always going to be the big ones on the heatsink. At least most of the time they will. And if we turn this around, this is kind of a strange layout for a stereo. Because if you look, there's these wires going across here. And you have 2 transistors here and here. And those are actually outputs. So here is 1 channel of the power amplifier, clear over here. And then down here is the other channel, and it's kind of split. You have the PNP transistor down here and the NPN complement up here. And so you have, they're all separated, and then the signals jump back and forth through these wires. So it's kind of an odd design. Now, I like to take a little brush, kind of get some of the dust out of the way when I'm working so I can see what I'm working on. You know, it doesn't hurt to leave the dust on when you're just testing around, but I'll make it a little bit easier to find things by doing this. So there's your transistors, and if you recall, it was the right channel, I believe, that was causing the problems, the one on this side. So I'm going to say that this one up here, these are the transistors that we're going to have problems with. And remember, we still have not looked at the schematics or opened anything yet. I will print them out eventually, but not yet. We're going to take it as far as we can without the schematics. Okay, let me get the camera down here a little bit. Just a little bit. And that'll make it a little easier to get at a better angle. And then we'll go from there. All right. Okay, I'm going to move. So let's take our meter. And so far, we have the dim bulb tester and the Phillips head screwdriver in our test box. And we have our meter. So far in our little plastic container, we only have 3 items that we've used so far for everything. Okay, so the first thing we want to do is take our meter, and we're going to set it to diode check. So on this meter, we're going to rotate this to here and then hit the blue button, and that puts it into diode check mode. And what we're going to do is I'm going to back this way off so that you can see what I'm doing and you can see the readings on the meter as we go. Hopefully that'll help a little bit. Yeah, I can see that. Okay, remember, these are TO220s, so it'll probably go base, collector, emitter. And so I'm thinking the base will be on the left here, if I'm correct. No, on the right. And So this green one is going to be the PNP and this black one is going to be the NPN. That's typically how they color code these transistors on this generation of equipment. So let's start with the NPN. So the P is going to want to be on your base. And so that'll be this here. And then if I go from, put the N lead or the black lead on the collector or the emitter, I should read a diode drop. So if I look here, that looks a little bit low. I mean, it should be about 0.5 or 0.6. It's 0.18. And then we check this, 0.18. So there's a good possibility that we have a short on this transistor, and that's the bad one. But we don't know yet. You could be reading across something, which means we may have to take that out of circuit to test it. But let's keep going. So the PNP is going to be the opposite. The N probe, or the black probe, will go on the base. And then the red probe, and then look at that one, dead short. And that's creeping up. So we have a base to collector short on this one. So just as simple as that, we found our bad transistor. Now, some people will take the NPN out and measure it, and if it's still reading good, they'll only replace the bad transistor, the PNP in this case. And if you're doing this for a business, for a customer, and you're going to just repair what it needs to get it running, then you would just replace the burned up part. If you're doing a restoration or you're doing this for yourself, do yourself a favor and replace the pair of outputs. First of all, you're going to get this pair, the same manufacturer, whether it's ON Semiconductor or ST Micro or whatever, whoever you use, Motorola, whatever, and make sure they're of the same complement to one another. And that's what we're going to do in this case. I'm going to replace the pair, and I don't really care if this one's bad or not. This one's shorted. We don't know what happened to this as a result of that. So we're just going to replace those. And that's not necessarily going to be the only problem, because we're going to have to go back and we're going to have to measure the driver transistors and so forth, because this is a direct coupled. When you see high-speed DC, is what this thing says, DC doesn't mean direct current. DC means direct coupled. That means there's no isolating capacitors between the stages. So if you short out a transistor here, the driver connected to it is directly connected, and it sees that short as well. So there's a good chance that not only the outputs, but all of the drivers are shorted, or some of them. There's also a chance that they're not, and these are all that's bad. Either way, we have to remove these transistors. Okay, we're going to add two more things to our little plastic tool container. One is going to be a vacuum pump to remove the solder. Now, this is a small one. You can buy these. This is available online, I think on Amazon or eBay or one of those things. You can also buy these bigger plastic ones that look like this. Most of them are a blue color. You can see I have a different tip on this one. It's very old. I've been using it for years, but it works very well. And these bigger ones just have a little more power to them, but they also have a bigger tip on them, and they're a little more awkward. So depends on what, like these are good for vacuum tube amps and things where you have a great big terminal that you want to remove solder from. And the other thing we're going to use besides this vacuum pump is we're going to use some desoldering wick. And again, the good stuff is made by Chemtronics. This is expensive, but to me it's worth it because it seems to work better than some of the lower end ones you get from China, but the Chinese ones work as well. You just might have to put a little drop of flux on those because they don't have, like, see, this one says rosin. It actually has rosin in the braiding, and it helps it to absorb the solder better. So we're going to use the combination of those two things to get that out. And to do that, you're going to need a soldering iron. And once again, you can buy just a plug-in type. Let's see if I have one handy. Okay, so all my plug-in soldering irons are stored away, and I don't feel like going and digging them out. But this is a Soldering Station. This is a more expensive one. You don't need to buy it. You can see it under here, kind of, sort of. It's a Hakko model FX951. And then I actually have the full station down there. You don't need that. You can buy just a cheap soldering station online. I think I did a review of a cheap one a long time ago that was donated or something. But just get a good soldering iron. We're going to heat this up. We'll take this out here. You just heat it up. Hit it with this. And we're going to take most of the big stuff off with this. And then we'll use the braid to get the rest of it out. Like that. Now some of these transistors are put in there using through hole. These ones are just, they just bend the leads around the side of the circuit board and solder them down. So that's how these come out. So usually these ones are going to have more solder to remove than the ones that are mounted through hole. There, we'll get you a little better zoomed in there. And again, with this desoldering braid, it's copper, so it's expensive. So you don't want to use it any more than you really have to, but it does do a good job of cleaning up the loose stuff here, or the pads, and making them, preparing them to for the new component. But there are many other ways to desolder. You can actually buy, a desoldering station that uses a vacuum pump like this that's heated. Very expensive. Even the cheap Chinese ones are can be kind of pricey. There's ones that are like one of these vacuum pumps with a hot tip on the end that you plug in. And I've used those before, and some of them surprisingly work really well, and they're very inexpensive. You can buy them online. So there's lots of ways to do this. Some people just heat the joint up and just wiggle the terminal loose that way. Just be careful, because if you stay on the pad for too long, you'll heat it up and the pad will come loose from the board. So you just kind of have to be careful. Now here's another problem I found. After desoldering the NPN transistor, look at this. The whole transistor is loose and not even mounted tightly to the heatsink. That's certainly a problem. Now the one that's shorted is firmly mounted to the heatsink. So how do you like that? Okay, I have this one loosened up already. And we're going to use another tool here in our box. We're going to use these larger sized needle nose pliers, and we're just going to loosen this off. Now the reason I'm doing this is because you can see this dial is in the way, so it's kind of difficult to get a screwdriver in there. Now you can get an angled screwdriver, or you can use just the bit out of a one of those screwdrivers with the inserts like I showed you. That's like a little set of these. But assuming we don't have this, these are hex head screws, so you can actually get a bite on them with your pliers, and if you're careful, you can just take your time and remove them. And these are tapped right into the aluminum heatsink. They don't have a nut on the back of them. So you just have to patiently take them out and remove them, and the transistors should come right out. So let me finish unscrewing this, and I'll be right back. So let me finish removing this, and we'll be right back. Okay, when you take these out, you have to be kind of careful, because there's going to be a mica pad or a silicone pad, depending on silicone pad, depending on where you got this from. And these mica pads, if you have one of those, are very, very delicate. So you have to be very careful taking those out. And you can use a utility knife, like a hobby knife, like this type of thing. And I think we're going to add this to our little tool kit. And that just helps take it off there, because these will crack very, very easily, this mica pad. And if we want to reuse it, you don't want it to crack. I usually just replace these, especially when they're all cruddy like this. But you can clean them in a moment. And we'll take this other one off. And this one might crack because there's that red paint on there. Nope, it didn't crack. So we got that off. And I'm reaching around the camera again. Okay. And we got that one off. Okay. Now we'll prepare that for the new transistors later. We'll get to that. The other thing that's going to be in here is, if you notice, this has a metal tab on the back of it. And that metal tab is connected to the center pin. So this is the same as the collector of the transistor. The collector is connected to this and to this. And there are transistors that are shaped like this that are all plastic. And the outside tab is isolated, and you don't have to worry about mica pads. Now, the idea of a mica pad is it keeps this metal collector tab from touching the heatsink. Remember, the heatsink is connected to ground, and your collector is connected to your 40 volts. So if the collector has a short in it, or if the mica pad is not in there, you're shorting this middle pin directly to the chassis ground through the heatsink. So another thing that you're going to have is you're going to have this little plastic, you see that in there? You're going to have this little plastic washer. And it's not just any normal washer, because it has a little shoulder in it. And you can see, here's part of your problem. This shoulder washer is broken. So the screw was actually coming in contact with the transistor, and it was shorting it to the chassis, and that might be what caused it to fail. See, these old plastic washers like this, these insulating washers, quite often the plastic will deteriorate with age, and they'll crack in this older stuff. So you may have to replace that little washer. Let's check this transistor and see out of circuit if it's still reading bad. So once again, we have our meter set to diode check mode. And remember what I said, the base is on the left, and this is a PNP. So for a PNP, the N goes on the base. So we're going to put that there, and then we're going to go from base to collector. And it's still dead shorted, see that? And if I touch the tab, it's still shorted because the center pin and the tab are connected together, as I told you. So this transistor is still bad. So what may have happened is when it was still just being insulated by this, and when we loosened the screw and unscrewed it, it was so tight in there that may have caused it to break. That's another possibility. Or this may have started the problem and then it shorted it. We'll never know. All we do know is when we put the new transistor in, we're going to have to put a new washer with it. Let's check this other one, and you can see how close that screw is to. They should have used a screw that's a little bit smaller diameter than this one, but you can see this one is intact, and you can see the washer all the way around. So it probably is okay. And we'll pop this out of here and see. Yeah, see, it's all intact yet. There we go. Okay, so let's measure this one. Remember, it was measuring kind of weird, but that's because I think we were seeing something in there. Now this is NPN, so the P is going to go on the base. So NPN. Yeah, see, that one's reading okay. So that transistor's not bad. I don't know if you're seeing what I'm doing here, but let's try it again. Base to emitter, base to collector, collector emitter, dead shorted. Look at that. So you have an emitter collector short on this as well, And I didn't even check emitter to collector on this one. And emitter to collector is okay on this one. So we have a base to collector short on the PNP transistor and an emitter to collector short on the NPN transistor. So they're both bad. Okay, if we look, the NPN is at 2SD313, and we're going to look for a complementary pair where there's an NPN and PNP pair that are made to work together in a modern transistor. This is a 2SD313, so we'll look that up first. And looking up here in the book, and you can Google search these, like 2SD313 data sheet, you just say, and you can usually find them online and download the PDF data sheet and look at it. I have it in this book here, and it's a NPN silicon. It's got a 60 volt Vmax, so they're saying that the collector to emitter is going to be 60 volts, and probably the base to collector will be 60 volts or something like that. Or I'm sorry, the base to base to collector. So not a real high powered transistor, 3 amps for your iMax, and it's a 30 watt transistor, and you can see it's just a standard TO220 case. And then here's a whole bunch of transistors that you can substitute it with. So you can use like a 2SC1964, 2SD317, so that would be a little bit, this is a 313, the 317 will replace it at 526. So there's all kinds of those. Let's find a suitable replacement in one of those. So here's what I found to replace these. To replace the 2SD313, which is the NPN transistor, we're going to use an MJE15032G. And for the 2SB507, which is the PNP transistor, we're going to use an MJE15033G. These are superior transistors pretty much in every way. They have a higher voltage rating, higher current rating, higher wattage rating, everything. So these will be very durable, good transistors. In addition, we're going to put a new set of these little shoulder insulating washers and a brand new set of high quality sill pads, which actually have a better thermal transfer coefficient than the mica and grease. So this will actually outperform it, and we don't have to get that white grease all over our fingers. So we'll clean off the grease off of the heatsink, and then we're going to go ahead and mount these up there, and we should be ready to go. Okay, so right here's how this is going to go together. You can see. And I just put a slight bend on these for now, and then we'll finish it when we get under to make it fit properly. And then we're just going to mount these down in here, and that should be it. And I can see if I can do it from reaching way over here. Okay, hopefully this thing will stay in focus while I do this. We're just going to take our pliers and just gently move these over back to where they were. And then we're going to tack them down. And the idea is you don't want to pull on them, you just want to kind of bend them. And then you can either use a small screwdriver blade or actually use your fingernail, kind of how I'm doing, to bend these down. And then we can solder them in. Okay. Just like that. And you don't want it to pull. In other words, you want them to fold over, but you don't want them to pull and fold, so that it doesn't put stress on the leads. So, all right. And we're going to get our soldering iron. And we're going to put these back in. See if we can do this standing up. It's better with gravity if we let these lay flat, but see if we can do this upright on the camera. If I have to lay the receiver down to touch it up later, I will, but these are, see seem to be going on pretty well. There we go. I think that looks good. Like I said, it's better with gravity, you know, if you laid the receiver down, face down. But those tacked in there pretty well. Should be good enough to check. So now we will get a cotton swab, and we'll get a little bit of isopropyl alcohol, and we're just going to clean the flux off. So, and you can buy isopropyl alcohol. You can get the industrial stuff at a hardware store, and you can also get just rubbing alcohol. It has a little higher water content. You just have to remember that. But you can buy that at like the drugstore or pharmacy type place. Both will work for this application. Now this is actually, since I use it for work, I have a whole bunch of it. This is anhydrous isopropyl. Anhydrous just means it's 99.9% water free. And it's like that when you first open it, but if you open the container and leave it to air, it will absorb a little bit of moisture out of the air, and it won't be exactly 99.99% or whatever, but it's still pretty low water content. The water content just leaves a little bit of residue. That's certain things that's important, but this kind of work, it's really not important. But some of the things I work on at work, the manufacturers very strongly insist that you use pure anhydrous isopropyl. They actually have bottles of it, you know, like single use. You open it, it's got a seal on it. You do whatever cleaning you're going to do, and then you throw it away or whatever, or use it for something else. And you open a new one for each time you do that. But anyway, that's done there. So now we're going to go through and we're going to check the driver transistors and make sure that we don't have a problem with one of those. Okay, let me put my mic back on. Looking topside here, we have a little more wrong than just those transistors. We have this resistor's burned up, and if it's a metal film, it may still read. It's just got really hot, but of course it needs to be replaced. And over here you can see these little diodes that may still be good, but look how corroded and green the leads are. And that might be from these capacitors leaking, but it might not be. We don't know. And if you look here, we have one driver transistor here and one here, and then there should be the preamp stage and all that, and that is going to be over here somewhere. And you can see these are those special, these C1845s, and this one right here. Now you don't see right here this metal can, and this, these are going to be two transistors that are in packages, and this is going to be for your differential input and your current mirror. And these are special transistors. There are actually two transistors inside here and two inside here. I don't know which one they're using for what, but this is for one channel, and then probably on the other side you're going to have the same thing somewhere. Yeah, right there is this one, and then the metal one, I don't know, is it under here? Where is it? It's hiding somewhere. It's probably under this ribbon cable somewhere, I would imagine. Yeah, under the, oh, there it is, right there. So we'll need to check all those, although I doubt that those are going to be bad. If anything, they may be noisy, and we'll have to check that later, but we'll have to get the amplifier working before we can check for noise and so forth. But really the main ones we want to check is, we're going to check this resistor, we'll check these two resistors, we'll check these emitter resistors right here, those ceramic jobs. They're probably going to be, yeah, they're 0.47 ohms each. This transistor and this transistor. So we have quite a few components we have to test. Now looking a little more carefully at this, This section over here is your phono amp. This integrated circuit is the entire phono preamp stage. And then there's just a couple of external components, and these diodes are part of that, which are going to need to be replaced. But we hope that this chip isn't bad. This chip has become unobtainium. Yeah, they're very, very hard to find. And if you can find a pulled one out of an old unit or even a new old stock, you're going to spend a lot of money, probably more than this receiver is worth. So we really hope that that chip is good, or we won't have a phono stage. We'll have to come up with something different for that. But if you look at the little lines here, right here, this section from this resistor over to here is where our, right in here, this is the amplifier section here. So this is what we really need to check. And we'll also need to check this thermal tracking stabilizer. Okay, I just went and marked with the little paint marker. We can clean that off with our isopropyl alcohol when we're done, so I know where these transistors are. I marked the two transistors, and what this is, because you have a PNP and an NPN transistor for the output, then most likely you will also have an NPN and a PNP driver transistor. Now that's not always the case, but I think in this one that is how it works. And the NPN will have a PNP on it, and the PNP will have an NPN, because these are cyclically pair drivers, I think. We're guessing at a lot of things here. But anyway, these little transistors, they usually go emitter base collector or collector base emitter. So the base will be the center pin. And we don't know that, but we're going to start out by guessing that. We're going to put our meter on diode check again. I'm going to back way out so that you can see everything. All right, I'll put this here. Hopefully it'll be a little bit easier to see. How's that? Set this up. Okay, so let's see. First of all, let's pretend the base is in the middle. If this one is a NPN or a PNP, then the N is going to be on the base, and we should see a diode drop on each side. And we do, look at that. So this is a PNP. If I reverse this, you can see I read nothing. And then if I go from collector to emitter, I read one way but not the other. See that? So there's something in the circuit that we're probably reading. Now this one will be the opposite then. So if I put my P in the middle, so it'll be NPN. Again, I should get a reading here, a reading here, and then when I go from, and there it is. And the reason that you're seeing the one direction that it's reading across the collector to emitter is because you're actually reading the junction between the base and the collector, I think, on the output transistor, because they're tied together. It's just the way these work, these Darlington configuration or Sakai configurations. That's how that works. So that's normal, which, long story short, transistors are good. So we're going to take a little bit of alcohol. We'll clean that paint off. And I'm going to say these transistors are okay, and we just had a bad output transistor is what was wrong with this. So, okay, in addition, we want to check those ceramic emitter resistors, because a lot of times when you have a short, I don't think they're bad because we were getting voltage out to the speaker terminals. But I will check them anyway, and they should read about 0.47 ohms each. And of course it would help to go to ohms on my meter and to back the camera out so you can see what I'm doing. Right? Okay. Let's get the glare off of there for the moment. And we're going to go from here to here. 0.8 ohms, and from here to here 0.7 ohms. And these are 0.47, but you have to remember your test leads are going to have maybe a half of an ohm to quarter to a half of an ohm that they're going to add to whatever you're reading. So the meter is going to read. So even when you touch these leads together, you can see you're reading about, well, in this case, you're reading 1/10 of an ohm. And then if you don't get really good contact through the solder, that adds a little bit of resistance. So those are most likely 0.47 ohm resistors. And they are reading. There's 0.6. So yeah. So your 0.5 plus your 0.1 something is going to be 0.47. That other resistor we can check from top side, and we're going to do that. So let's flip this down. And let's go down and look at that. And we're going to test it, and it's obviously we're going to have to replace it, but we're going to need to get the schematic out to see what that is. We don't really know what it is. And actually the resistor is wide open. So if we don't have a schematic, we're going to get one. I mean, I just have to print it. I think I have it upstairs. But if you don't have a schematic, you can always go to the other channel and compare. And looking at this one over here, I believe this is the resistor we wanted to see, and it looks as if it is red, red, black. Let me zoom the camera in and see if I can see through the camera better than my eyes can see from there. Yeah, red, 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 black. So that's 2 and no zeros, so that's a 22 ohm resistor. And we're just going to make sure that that's what that is. And if that is the same resistor, and we'll check the connection of that and so forth. If that resistor is connected to the same part of the circuit on this side as ours is, actually, I'm wrong. That's not the one. It's right next to this here. See? And we'll just locate it. And we'll trace it through and make sure it goes to the same place on the one channel as on the other. So here we go. You kind of see that down in there? That is a orange brown, which is 330 ohm. That looks more like what we're looking for there. And again, I'll make sure that's the correct one, but I think that is, because it goes from, looks like it goes from this side of the resistor to the base of the transistor. I'll just ohm that out and make sure that that's where it's going. And it is. So I'll just have to go over here and make sure that's the same connection. So if I go from here to the base, yep, so that's the same one. So that is a 330 ohm resistor. So we will need to replace that 330 ohm resistor right there. Let me see if I have one. Okay, here's what I found. It's a metal film, and it is 330 ohms if I turn it around this way. And this is one of those 5-band resistors. So that would be 3, 3, 0, and then there's no multiplier. That's what that black is. So 0, other zeros. And then this is going to be your tolerance here. And I'd have to look that up, what that tolerance is. Probably like a 1% or maybe a 5%. I don't remember. But anyway, this is the 5-band type resistor. So the main difference is you have 3 numbers and then the multiplier and then the tolerance, instead of having 2 numbers and the multiplier and the tolerance and then no 5th band. Hope that makes sense. So this is a 330 ohm resistor. Hope I'm in frame here, and I hope this is the right transistor. I think it is, or the right resistor. I'm pretty sure it is. Okay, that one's out. I'll put the new one in and we'll be right back. Okay, and our new resistor is installed. So I think we're ready to try this. All right, I think I got everything in shot here. So let's turn this on, and if we got it right, the light should again flicker on and then dim back down, and then I should be able to measure, and we should not have any voltage on that channel anymore. Very good. It's a good sign. So let's go from here to here, and look at that. No voltage. We go from here to here, no voltage. And this offset, if we go to millivolts now, this is your DC offset, and you want that to be as close to 0 as possible, but you're almost always going to have a few millivolts in there. And we haven't touched any of the alignments, of course, in here, but it's now safe to connect some speakers. So we'll check this for a little bit longer. We'll let it run for a little bit, and then I think we should be able to connect some speakers and see what happens. Okay, we repaired the amplifier, and so far here's all the tools that we used. If you take a look, that's it so far. Okay, the moment of truth. I have speakers connected, and let's move this bulb so I can get to the volume. I'm going to turn the volume down. Speaker A on, FM mono. We don't even know if the controls need cleaned. I don't know anything, but let's turn it on and see what happens. I still have the bulb connected, and let's go. All right, so we have a light here, signal light, and tuner. Let's turn the volume up. And it works. Wow. It works. It works really well. Let's see if we can get the balance to go back and forth. I'm going to get on some static here. If I can, there. That way we won't get any copyright strike. Left or right, left, and it's kind of bad, so the balance control definitely needs cleaned, and we can clean all that stuff, spray them real quick, but it's fixed. Now what I will do is I will replace those output transistors on the other side so they match. I just want to have the same type of transistor on each channel. It's just a force of habit that I do. That way they're, both channels are the same, so if we did introduce any slight difference, which I highly doubt, they're going to be the same. Anyway, let's do that real quick, and then we'll clean the controls. Okay, I changed out these other transistors, and they're still good, so I will put them in my used transistor assortment that I use for people that just want something original, and we just need to replace same with same. So I keep a few around for that, typically. Anyway, the other really cool thing about this tuner, as old as this thing is, this actually has the touch-sensitive phase lock loop tuning. So if you look, I'm locked in on a station, and you can see when I touch it, watch this green indicator. See how it turns from green to red? It unlocks, and then when you let go, it will lock the frequency in on the station. Very cool. I mean, the other stereo that you saw there was two other ones, I think, in my videos. One was the really expensive Pioneer TX9800, and the other one, I believe, if I'm not mistaken, Yeah, it was the 1280 and the 1980. So the 1280, the 1980, and the TX 9800 were the three tuners that had that touch sensitive, you know, locking. So it's pretty cool. This is a very capable receiver for what it was back in the day, and it wasn't very expensive at all. And it has really good sound. The only thing I don't like about it is it does not have a speaker protect circuit. Now we can add one of those, but I don't know if I want to do that in this video. So what I think I'm going to do right now is let's take an inventory of what we've used so far. So we have our container out, and so far all we used to do this repair, all the troubleshooting, the repairs and everything, was the dim bulb tester, a standard digital multimeter, a pair of wire cutters, a pair of needle nose pliers, a small screwdriver, a Phillips head screwdriver, a vacuum pump for the solder, a hobby knife, a little brush to clean the dust, and of course the desolder wick, and of course we used some solder and a soldering iron. And that's it. That's all it took to do all the service on this, and we didn't even break out the schematics yet. Now what I will have to do yet to finish everything is we're going to have to check the bias and offset adjustments, and in order to do those properly you really need the service manual, and we would print that out, and you've seen me do that on many other stereos. There are 2 pots on each amplifier, so that tells me there is a bias and DC offset adjustment. Some of the cheaper receivers like this don't have an offset adjustment, so again, a nice feature that they added to this low-cost receiver. So we can do that. We will have to replace those corroded diodes because of the corroded leads on them. I think they're still working, but the leads are corroded. And because of that, we may want to spot check a couple of capacitors. And we can use our meter on Capacitance Test, and we can also use the diode check to see if there's any kind of leakage, although that's not the ideal way to do it. You could also use, we didn't use any of these in this video on purpose, but you can use one of these little testers and test the capacitors with them. You could obviously use an ESR meter or a capacitor analyzer, an LCR meter. There's all kind of crazy expensive things you can use, but you don't necessarily have to have those to service something like this. So this is all we used. Now, here's where we are. I'm going to end this video because I just wanted to show you how few tools you really needed to troubleshoot and repair a basic problem like this on a receiver. If you want to see me complete this by doing the alignment, replacing those couple of diodes, and then possibly we can add a speaker protect circuit so that if this ever happens again on this receiver, it won't damage the speakers, let me know down in the comments section, and I'll do a follow-up video to this. Other than that, this receiver, really, we can put it together and, you know, sell it or whatever we're going to do with it. This is another one that's probably going to end up going up to Flipside Records, but I may tinker around and put one of those speaker protect circuits on there though before I do. Anyway, that is it for today, and as always, I wish you all peace, joy, happiness, and good health in your lives. I hope this was a little bit interesting to you, because I think a lot of people think you need a lot of crazy, you know, fancy equipment to service these, but you really don't. The most advanced tool that you have in your arsenal is your mind. Always remember that. If you have the ability to reason and figure these things out, you can do it with very minimal tools. The tools always make it easier, you know. And, you know, this coming from a person who is, I will admit, I am a tool addict and test equipment junkie. I love the stuff. But that being said, it's sometimes good to do it this way. It's good exercise for your skills and good exercise for your mind. And it also proves you don't need a whole lot to do this. So again, I wish you all the best. We will see you again real soon, and let me know down in the comments section if you want to see more on this. If not, I have a ton of other really interesting things coming up. So if you'd prefer me to skip along and do that, I'd be more than happy to. No offense taken here. Take care, everybody. Bye-bye.